Hi, I'm Jonathan Oxer, and this is SuperHouse. Okay, so this is what it looks like to be a circuit board lying on my workbench looking up at the camera. Ugh. That's awkward. When I'm working on PCBs on the bench, one of the most annoying things is trying to put connections in place temporarily and take measurements and then use your hands for doing other things. It might be when you're trying to debug a problem on a board or just investigate how a board works. You know, the classic thing is you'll grab your multimeter probes and get yourself a ground connection and then get a connection on here to measure some signal, and then you discover I've got to press enter on the keyboard or, you know, to load some code or do something. So wouldn't it be nice if you could put your probe in place, put it where you want it, and just let go and have it magically stay exactly where you want it to be? That would be fantastic. That sort of thing has crossed my mind many times. Never even thought about trying to solve the problem. But then I came across this project on Thingiverse. It's a PCB workstation designed by an Italian forensic engineer. He works on PCBs of seized devices and, you know, trying to do forensics on them. And so he designed this system that allows probes to be put in place on a PCB and then stay in place by 3D printing and assembly. Looks super cool. I've done a little bit of an experiment and I've made up one of the probe assemblies. I just wanted to see how it would turn out. And the idea is that this mounts on a base and then you can adjust the position, and then this acts as a test probe that you can connect onto any part of the PCB. Just leave it in place and then your hands are free to do other things. So I've already printed out the parts for all of this. I haven't assembled it yet other than this one little test probe. Over here on my workbench I've got a collection of the parts and I've laid them all out so that we can see exactly what we need. So we've got the base here, which is what everything is going to connect to. There is little assemblies which have got some M5, I think they are, M5 bolts and wing nuts. These are going to be mounts to mount a PCB on here, whatever device it is that you're going to be testing. Each of these forms one of the test probes, and I've color coded a couple of them, and the rest of them I'll color code differently. We also need some hookup wire, some heat shrink tubing. I've got a couple of little self-adhesive rubber feet, some pin headers, and I've also got, and this is the magic thing, these are acupuncture needles. The amazing thing is that you can buy these for only a few bucks for like a packet of 100 of them. They're stainless steel and they are incredibly sharp, so those are going to be our test probes. The idea of using these as test probes is a stroke of genius. And I've also got some ferrules and a ferrule crimper. I'll show you why we need those in a moment. First I'm going to put these little PCB mounts in place. They are double-ended, so they've got a straight mount on this side, a corner mount on this side. And you can either mount them coming in diagonally or coming in from the side. That way, depending on the type of board that you're wanting to attach and what the dimensions are, you can adjust it to suit. It uses these little M5 bolts. These are probably a little bit longer than needed. The important thing is to get one that's got a hex head in it, because what happens is on the bottom of this mounting bracket, you can see it's got these slots that are inset. The bolt has to drop in and it needs to be able to slide along in here but not rotate. So I'll just drop it in, put that one in there. Actually no, what I'm going to do is put it in from the side. Mount this one in here. And I'm going to put on a washer so that the wing nut doesn't bite down into the plastic. So what we should be able to do with the nut loose is then just slide that along, and the nut slides in that slot. Now, one thing that you'll notice once you do this is with this sitting down on the bench, it tends to jam up. It has to be lifted. That's one of the reasons I'm going to put those rubber feet on in a moment. Give it a bit of clearance under here. So I'll just stick all of these in place. There we go. So now I've got all the slide mounts in place, the PCB mounts. We can put a board in, get these out of the way, and we could clamp it in place just by sliding those in and then doing up the wing nuts. Leave that in there. So it's just supported on two sides at the moment, but as you can see, it makes a nice flexible mounting bracket for whatever shape your board happens to be, as long as it's no smaller than that and no bigger than that. Now, making the little crane arm assemblies is where I ran into my first problem. If you look at the way they mount on this base, they have this little part here which goes into this hole in the base, and the idea is that everything mounts in here and you can rotate it and you can just plug it into a different location. The problem is that different 3D printers have different tuning, they have different tolerances, and the design files that I downloaded from here, once I printed them out, left a little bit too much of a gap. So when this goes into the hole here, it goes in a bit too easily and the whole thing flops around. And the STLs for these are published on Thingiverse. Giuseppe posted those with the project, but not the design file. So what I had to do was generate my own model of this particular part. This is the original, and this is my version that I recreated in Fusion 360. And I did that just so that I could tune some of these parameters. I could move them by tenths of a millimeter on the diameter to get the thickness just right. And what I was going for was something that was a firm press in, and it holds its position quite securely, and it doesn't flop around. So what I'm going to do is I'll publish my Fusion 360 project for this, just for this part. The rest of it, it's all printed exactly as Giuseppe intended from his files on Thingiverse, but you may find that you need to tweak the dimensions on this peg a little bit. Now, one other thing is, in this design you can see that there is a hole down through the center, and that is designed to have a screw put in to strengthen this peg, because when this is mounted on the base, all of the force goes through that point right there. Potentially the weakest spot is the layer bonding just at the top end of this peg, and so Giuseppe intended that you would put a little self-tapping screw down into the bottom, and that would act as a reinforcement for that peg. On my design I haven't put that in. I haven't found it to be necessary on the test version that I did. But if you're wondering why that little screw hole is there in the original design, that's what it's for. I did a little bit of color coding on mine, and the needle holder, which is the part that sits on the end, I printed one of them in black. In fact, I printed both of these in black, and then I spray painted this one red because I didn't have any red filament, and I painted the rest in blue. And that's just so that there's a quick visual indication. I wanted dedicated probes for ground and power, and then the others for data connections, whatever I might need to use. There's also a little M4 nut on here. Once again, you need to make sure that you get the version with the hex head on it, because it has to fit through this particular part, and the hex head interlocks with this slot so that it doesn't turn, and that allows it to slide up and down but not to rotate. We're also going to need some acupuncture needles for these, and they need to fit into these pieces right here. Now, these I found were actually one of the hardest bits to print out of this whole design. It doesn't have a single flat face on it anywhere, which means there's no obvious way to put it down or orient it on the 3D printer bed. I tried printing them vertically with supports and horizontally with supports, and it was generally a little bit of a mess, so they'd need a little bit of cleaning up. I ended up having a few that didn't print properly, and I found the best way was to print them horizontally like this, so that they would be lying flat with supports, and then break them off. And they have a little slot on the end and a hole, and that is designed to mount the acupuncture probe, and it's meant to clip in there, but different size probes. I don't think I've got quite the same as the ones that were used by Giuseppe in his original design. So what I've had to do is drill these out, and this one I've pre-drilled. The handle on the acupuncture probes, it's about 1.3 millimeters, and I've got a 1.5 millimeter drill bit, so I just drilled through the existing hole to clean it up, and you can see now that it's a little bit of a loose fit, but it goes through. So all I do is put that in there and then put a drop of super glue in there, and that holds it in place. So for now, what I'm going to do is assemble the rest of this. This is Giuseppe's original design, so I'll get rid of that, replace it with the with mine, and then the vertical part of the base goes in there. It's a nice firm fit, but I'm going to put a drop of super glue in the bottom and just make sure that goes in there permanently. And stays nice and rigid. So then we need the bolt to go through here, and put the arm on here, on with the washer and the wing nut. So that gives us an assembly that we can then adjust the angle, we can slide it and adjust it vertically, so we can move the end to whatever position we need and then just spin the wing nut to tighten it up. Now these little needle holders are a press fit into the end. It can be a little bit tight, but if you clean it up with a scalpel, you can just trim it and then it goes in there like that. I'll just move this up so it's out of the way. Set the acupuncture needle through so that it sits with the handle part way through like this. And then what I'm going to do is, for now, I'm just going to sit this on here, put a drop of super glue into this spot so that it doesn't move, drop of super glue onto the handle so that it bonds to the holder. Then I'm just going to leave it for a little while. I'll do that for each of these assemblies so that I've got them all ready to go, ready to hook up the wires, and we'll come back to it in a moment. All the acupuncture needles are glued in place, and I've put heat shrink over the bodies of these as well. You can see I've used black and red on here and clear on the others. Comes down to close to the point. That's just so that if I'm setting this up and there are probes that go in close to each other or they cross over, they won't short between each other. It's just the last 5 or so millimeters that are exposed. So what we need to do now is attach wires to them. I'm going to do that using these things. These are called ferrules, and they are really awesomely cool. They're normally used with wire to terminate the end of multi-stranded wire like this. So I've just stripped this bit of wire off and it's got a few strands in it. Often you'd want to put this into a screw terminal, and sometimes as you're poking it into the terminal, you get a bit of a strand coming out. It can be kind of annoying. What you do with the ferrule is that you feed it over the top, and then this little device squeezes it together and turns it into a square shape, but it crimps it down. And that's now firmly attached to the end of the wire, and you won't get any strand. So you can put that into a screw terminal, and it works really well. What I'm going to do is use that to attach wires to the backs of these. Now the reason for this is that the acupuncture needles are made out of stainless steel. And I don't know if you've tried soldering to stainless steel, but it's pretty much impossible. You cannot get the solder to stick. You can flux it up, you can make sure you've got lots of heat on there or whatever. The solder just won't stick. Now, with some types of acupuncture needle, I think they have a regular steel end on them. So you can solder to that. But what I'm going to do here is cheat. I'm going to take this little ferrule and if I can get this open, carefully pop the plastic backing off it, because I'm not going to use that, and then grab one of my bits of hookup wire and then feed the ferrule over the top so that the wire and the end of this little acupuncture needle are bound together by the ferrule. Then I can crimp it on, and hopefully this will keep everything nicely electrically attached and mechanically attached. So if I slide that down, you can see there that the ferrule is going over the back of the acupuncture probe and over the wire. So now if I grab my little crimping tool, squeeze that up, it's now got a very strong mechanical and electrical connection onto it. So we'll now have continuity from that wire through to the probe. And then we can just guide this bit of wire down and push it into these little clips. depending on how thick the wire is, you might need to use a scalpel to open this up a little bit and attach that in there. And at the other end, you can see that I have soldered a single pin header on here, and then I've put heat shrink over the back of it. Now you might choose to use something else. You could put an alligator clip on here, or you could put a banana plug. That could be quite useful, because then you could plug this straight into a multimeter or into a bench power supply. So I might end up making some different probes over time with different connections on them. But I figured that these little pin headers are probably really useful, because not only can you put them into breadboards, you can connect probes to them. Like if I grab my oscilloscope probe from up here, it's got a hook fitting on the end, so I can just hook it on like that. That's convenient. And I've got alligator clip outputs from my power supplies. So the other thing is that you can plug these into headers, like on a USB to serial adapter. Now with a few of these test probes finished, I'm going to test this by sticking this wheelchair motor controller on. This is a project that I've just been working on with my friend Chris, and I'm going to mount it in here, and it has a CAN bus interface on it. Oh, got to get that right. Sit that in there and clamp it in. It'll be a bit of a test of using this as a jig. Should be interesting. So just get it all firmly mounted in there, and then I'll be able to make some connections. But to actually make these connections, it's going to be much easier if I do it under the microscope. And part of the way this is designed, the way Giuseppe intended this to be used, is to put a microscope over the top so that you can see where you're making the connections. With the board under the microscope, we can also immediately see another benefit. Now, these multimeter probes are my favourite probes, and they're extremely sharp. They're like a needle. But even these, if you put them under the microscope, it looks like you're working with a tree trunk compared to the size of these pins. And these aren't particularly small pins. It's quite large. But now if we bring in the other little probe, so that's the probe which is made from the acupuncture needle, put it side by side with the extremely sharp multimeter probe, and it's chalk and cheese. Look how much smaller that acupuncture needle is. So we can use that to make very accurate connections in here, and because it's a little bit springy, you can apply a little bit of pressure and it will just sit there and stick into the solder on the target pad. So for making connections, this is fantastic. It's actually even better than quite decent multimeter probes. So now I need to make a connection just in here, and I'll loosen this one up a little bit. This is going to be my data connection onto the transmit line. So I'll move that into position, push it down into place, do a little bit of a jiggle to get it into the right spot, because it's very small. It looks big under the microscope, but it's not in real life. Okay, so that's in place. And now you can see that I've got my hands free. We've got the connection in place on the pin, and now I've got a lead here that I can connect to my oscilloscope. I've hooked up one of the little test probes to ground, and I've got a couple on the USB connections, D plus and D minus on USB, and then I'm feeding those into my oscilloscope on a couple of channels so we can see the differential on the USB line. Something that I've just discovered as I've been doing this is that having a pair of tweezers is really handy, because what you can do is get the probe into approximately the right position, but as you can see, these are quite close together here, so getting your fingers in there to do anything is very awkward. But what you can do is just reach in with a pair of tweezers and grab the probe, and then you can pick it up. Because it's springy, you can relocate it a bit, put it where you want it, let go, and it will stay there. So with those probes in place, we now have the trace coming up on the screen. So I'll just pause that, and we have the USB data that is coming out to the host computer. And as you can tell, I'm not using my hands right now, but we have those connections going through to the oscilloscope. So this is working out really well. It's remarkably easy to make the connections exactly where you want them to be, and working under the microscope just makes it even better. So I am super impressed with how well this has turned out. It's a fantastic design, and using the tweezers to just pop the probes into place Works actually better than I expected. Feels a little bit awkward at first trying to get the probes aligned and do up the butterfly nuts without everything moving all over the place. But if you get it approximately right and then just pop it into place, works like a charm. It took me a couple of days of printing, I suppose. I was just printing off a few pieces at a time while I was doing other things. But Giuseppe, who designed this, also offers this as a kit. So if you don't want to do all the printing yourself, you can just order a kit from him, and he'll send you all of the 3D printed parts. And I think it comes with all the other hardware that you need as well. So that's a really good option. It's a fantastic project. I really highly recommend it. And if you want to use my tweaked version of the base so that you can pull it into Fusion 360 and then adjust the spacing to make it fit your 3D printer better, the link for that will be on the page for this video, so make sure you have a look at the link below. I am super impressed. It looks impressive and it works even better than I could have hoped. So, see you next time. Go and make something cool.